Okay, no, I think we're good. Okay,
We might just like.
tinker, and that's fine.
There.
Do you want to get started then?
Aren't you doing this stuff?
Yeah, that's what I'm saying.
Yeah, wait. Yeah.
Okay.
Can everyone see the screen?
Are most people on the Zoom meeting, or do you guys want a little bit more time to get on? Question mark. Wait, like thumbs up if you're on the Zoom meeting, or like raise your hand. Okay. It's like half of you. Okay, we'll give you guys like one more minute to get on the Zoom meeting, and the slides. And then if you don't know how to get there, there's a Discord link that I wrote down. So if you want to type that in to join the hack Discord channel. Okay, for everyone on it, if you want to go ahead and sign in with the QR code, this is just so we can track your attendance. Yeah. Like 1 minute.
Just use this.
No, but I want to see what's on it so I can see what's coming. I want to see what's on it so I could see what's coming next.
Oh, you can do like presenter of the.
Wait, no, just keep it as normal. Wait, just keep it as normal. Like it's fine. Just keep it as normal.
Yeah. So.
Okay, we're gonna go ahead and get started. If you guys want to follow along in the slides, that should be posted. Oh, sorry. That should be posted on the slides in the Discord. So what is Swift? First of all, thank you everyone for showing up. We're so happy to see like the room is filled up. That's really cool. Yeah, so what is SwiftSchool? So this is going to be a 4-week hands-on workshop series. You don't have to have any knowledge in like programming, anything. And the goal of this workshop series is to learn the basics of Swift and SwiftUI, which is basically a way to develop mobile apps. And I'll get a little bit into what the difference between them is. We're going to be integrating little mini projects into each of our workshops. And in case you guys don't know, it's going to be bi-weekly. So this is going to be our first meeting. And then we'll have our second one on week 5, week 7, and week 9. And the goal of like structuring it that way is even if you're not able to come 1 week, you can still be able to follow along to whatever project that we're going to be leading on that week. Yeah, and this is designed to be fun, friendly, and practical. So we try to make our slides engaging, but if at any point you guys want us to slow down, speed up, maybe elaborate more on a topic, please feel free to raise your hand, ask questions, stop us. And there's also a couple of hack officers just sitting around the room. So if you need help with anything, just like raise your hand. Someone will probably notice and come by. Okay, perfect. So as for the curriculum, this week for today, Sebastian and I will just be presenting a very basic like intro to Swift, intro to SwiftUI, and we'll also be covering the basics of programming for those who may not know that much about it. And then in the following weeks, we'll be focusing on one project every single week, where you get to like have hands-on application of what you learned. Okay, so before we get started, let's set up. So to build an iOS app, we're going to be using Xcode, and Xcode is Apple's IDE, and the IDE is basically just where you type your code. The thing about this is, I think to build like Apple apps, you do need like a Mac. So if anybody has like a different type of device, I'm not really sure if you'll be able to download Xcode or like code. I think Swift works everywhere, but I don't think SwiftUI works everywhere. But you're still welcome to like follow along and learn. Yeah, I'm assuming is everyone here? Have you guys like taken like CS30, CS31, 32, or yes, no, kind of? Okay, well, if you have, you should probably have Xcode downloaded. If you haven't, please download that now if you want to follow along a little bit later on. Okay, yeah. I think this next slide just kind of going over basically what I said. What to expect is going to be bi-weekly 1.5-hour workshops, follow along code sessions. We can skip that. And then I also included a list of resources for those of you guys who want to do a little bit more in depth of your own self-learning. You could check out the SwiftUI docs. There's a good resource called 100 Days of Swift, and just various other things if you guys want to check that out on your own time. Okay, perfect. If everyone's good, we can jump right into our agenda. So we're going to be starting off with what is mobile development. Okay, so what is mobile development? The name is kind of self-explanatory. It's like the process of creating apps and mobile devices. And this would be things like smartphones, tablets, watches. And they're designed to be touch-based because, like, compared to a computer, you're using a lot of taps, a lot of swipes. The screen size is a lot smaller, and they're made to be more responsive. I think, like, if you're using your phone, you probably want things to load right away. So speed is really important when it comes to mobile development. Okay, so there are two main ways to build mobile apps. There's native and hybrid. And what's the difference between these two? So, native apps are built specifically for that platform. So, I think the easiest way to think about this is there's iPhones like Apple, and then there's Android. And basically, if you wanted to build like an Apple app or like an iPhone app, you would use iOS. That's like using their specific, or no, you would use like Swift and SwiftUI. That's their specific like native language. And then for Android, you could use like Kotlin or Java. And the pros of native apps or native languages is they give you more access to that like systems features. So for example, like if you're making an Apple app, you would probably want to use Swift because you get more access to the different types of features on that. So the performance is better, the UI experience is better. But the cons of this is if there's two separate like platforms, let's say you want to make an app and you want iOS users to be able to use it and also Android, you would have to make two separate code bases. So the alternative to that would be hybrid or cross-platform. And this is basically when there's one code base and it runs on multiple platforms. So you only have to write the app once. So this is things like React Native, if you guys have heard of that, Flutter, Expo. And the pros to this is it's faster to make because you only have to make the code base one time instead of twice. And then the cons is there's a little bit less performance because it's not as app specific. Oh yeah, does that make sense to everyone? The difference between like natives versus hybrid cross-platform? Okay, okay, perfect. Okay, next we'll go a little bit into what is Swift versus Swift UI. So Swift is the programming language created by Apple, and it's used to build apps for Apple ecosystem. So think your phone, your Mac, watch, TV. So this handles things like the logic, the data, and the decisions. So this is kind of like if you guys have taken an intro to programming class, it's pretty similar to what you already know, things like variables, functions, loops, and all of that. It's basically driving all the logic behind the app, and that core like functionality of the app. And then if that's Swift, then what is Swift UI? Swift UI, in case you guys don't know what UI means, it stands for user interface, which is kind of self-explanatory. It's like how the app looks. So Swift UI is a tool to help build the app screens. And you code in Swift when you're using Swift UI. And this is to design what the app looks like. So in Swift UI, you would be specifying and building out things like the text, the buttons, the images, the layout and the navigation, and then also the different animations. So if you want to compare them, Swift is the programming language and Swift UI is not a language. It's like a UI framework. Swift handles things like the logic and data of the app, and Swift UI handles like the visuals, how it looks. Um, yeah, and then Swift is used everywhere. Swift UI is mainly for building like the UI or the user interface, how it looks. Okay, does that make sense to everyone, the difference between Swift and Swift UI? Okay, perfect. So the next topic is intro to Swift. Wait, can everybody raise your hand if you've taken like any sort of intro to programming course? Okay, yeah. So that's kind of what we expected. We're gonna assume most of you guys know like the basics of the basics. So for this next part, we're just gonna kind of do a little speed run of Swift syntax. It's probably very similar to what you already know, but there might be a little bit discrepancy, so we can just run over all the different things really quickly. So starting off, we have variables versus constants. This is basically just like storing a value and assigning it a name. If you want to have a variable that you can change, you can use the var keyword. If you don't want it to change or you want it to like stay constant, you would use the let keyword. We have strings. This is basically just like any text data, and you can wrap these in quotes. Here are some common operations on strings. You can uppercase, you can have the count. All the like methods for everything that I'm going to be covering in this section is probably really similar to like what you already know. If you learn like C or Python, it would just be like the Swift version of that. And then if you wanted to find exactly what operations or methods exist for everything, you could probably search that up and there should be like a long, long list. Okay, numbers, ints, doubles. the key operations, the basic math operations like adding, subtracting, multiplying, dividing, and then type conversion. If you want to convert like a string to a type of int, you can wrap it with like the int, and then same thing with the double. Yeah, I'm gonna go through this part like pretty speedy. Booleans, true or false. String interpolation, this is basically when you're just like plugging in a variable into a string, and the syntax for that is going to be a backslash and parentheses. I included an example here, and that's just how it would look, assuming you guys are all like on the same slide as me. Okay, this next part I can kind of talk about a little bit more in depth. So we can review some common data structures. First, I'll talk about what a data structure is for those of you who might not be as familiar. A data structure is basically a way to store and organize data, and there's a couple different types of these based on what you want to do with that data. The idea is it holds different types of values, multiple values, and it's supposed to make it easy to access and use. And like I said, there's different data structures for different use cases. In the picture, you can kind of see there's different like shapes, and that's just how we like to visualize different types of data structures. And okay, so what does this have to do with making an app? Like, we're trying to build an app. Like, why do we care? The reason is because the data structure you use matters, especially for like your backend. If you have an app, we assume you're going to be holding a lot of data. And if you want to be able to access that data, choosing the right data structure can make your app go a lot faster. It can make your code a lot more cleaner and readable. And it'll just like in the long run make your app like perform better. Okay, so I'll run through some basic data types or data structures. The first one, arrays. I'm sure you guys probably know this. This is just an ordered collection of values. You can access it by index, and arrays are zero index. So the first item is going to be like index zero. These are best used when order matters, when you need to loop through an item, if you want to access an item by an index. And some examples of use cases, like with an array in particular to an app, could be like a list of posts, like Instagram post or something, a shopping cart, a to-do list. And here's the syntax for arrays. It's pretty standard to what you probably know already. You could do the same things, add to an array, access an item by indexing. Okay, next is dictionaries. So dictionaries store key value pairs. I included a diagram that hopefully kind of like helps you visualize that a little bit. And the idea is you would use a dictionary when you want to look up things by key. So if you know like the name of someone and you're trying to get information related to that name, then you could use their name as the key. And then this is used when you want really speedy lookup, like really quick lookup. And some example use cases, so like a username. Let's say I want to like store test scores. The names would, or the keys could be like the students' names, and the values would be their scores. And then in an app, this could be like the app settings. The keys could be the different types of settings, and then the values could be the toggle, like whether it's set to true or set to false. Um, yeah. And then I have a slide with just basic syntax of a dictionary. You use brackets and you can access a value, assign a value, get the keys, get the values, and get the count. Yeah. Is this like pace good? I know I'm kind of talking at you guys a lot, but I'm just trying, I want to get through all the like basic code stuff first. Is it good? Slow down, speed up. Like ish. Okay. Okay, perfect. Okay, the next data structure is sets. So sets are unordered collection of unique values, and these are also used for very fast lookup. The idea is you want to use a set when you don't want any duplicates. You just want to check if something like exists in a collection, and order doesn't matter in a set. So some example use cases of this could be like selecting a tag, favorite items, and different types of permissions. Yeah, and then the syntax for a set is pretty similar to an array, but the different methods are a little different. Or not an array, a dictionary. The methods are a little bit different. You would use like insert and remove and contains. And the idea is this is all very like fast. Okay, and then the last data structure I'll cover is enums. This might be a little new to some of you. An enum is basically a fixed set of like related options. And so the idea is you'll use this when you only have certain values that you want to use. So if you look at the example, the enum, the name of it is like light color, and there's only three options, green, yellow, red, because we know the light colors can only be one of those three options. And the idea is you're only limiting the values that can be used to whatever is described in the enum. So this could be some example use cases could be like app states, so like loading, success, and error states. Directions, there's only northeast, southwest, and then user roles, like admin versus user. You only have like two or three types of different roles. Okay, yeah. And then the syntax for that is just like the, what is it? Curly brackets. Um, and then, yeah. Okay, so really quick run through when should I use which type of data structure. If I need order, you could use an array. If you want like a key-based lookup, use a dictionary. If you want uniqueness, use a set. And then if you want fixed choices, use an enum. This honestly won't really come up in our demo today, but this is more for like later workshops and later projects. This would probably come in handy. Oh yeah. And then for the like basic Swift syntax, we're almost done. We just have a couple last basic topics. So type annotations, this is when you can specifically define like what type a variable is. So Swift has something called type inference, which is basically if you assign a value to a variable, it can infer what type it is. So for example, let's say like let name equals Taylor. Swift knows this is a string, it's wrapped in quotes, but if you want, you can also explicitly state that it's a string. If you look at the syntax, it's gonna be a colon and then the type that it is. And this is really helpful for having like a clean code base, like a readable code base. And then another thing, if you're creating an empty variable that you haven't assigned a value yet, but you know later on you only want to use it for one type, this is where type annotations would come in to help keep your code like organized and clean. Okay, if statements, I think most people should probably know this. This is just like different outcomes based on like whether your code meets the conditional or not. So you have if, else, if, oh my God, if, else, if, and else. Um, Switch statements, this is just kind of like a different way to write an if statement. It's also like conditional checking. You use the switch case keywords for this. Okay, and then ternary operator, this is another way to write if-else statements. You kind of just reformat it a little bit differently, and this is the idea is you can just shorten the if statement a little bit. If you guys want to look at the syntax, it'll be kind of hard to like explain through talking out loud, but I included some diagrams, so if you guys are following on the slide, hopefully you can kind of like see. Okay, for loops, this is basically when you're repeating code over a range or collection. Very similar to what you're probably used to. You could say like for I in a range. So if I want to do for I in 1 through 5, the syntax is like up there. And then for iterating through an array, let's say you have an array called fruits. If you want to go through every single fruit, it'll be for fruit and fruits. Okay, functions. Functions are just reusable blocks of code. These can take parameters. So in my example, my function is called greet, and the purpose of this function is to print hello. So when I call the function, it'll print hello. But if I want to take in a parameter, and a parameter is basically like being able to pass a value into this function so it can use it. Let's say I want to be able to greet someone in particular. Let's say I want to greet Hannah. I can pass in Hannah to my function, and then it'll use her name and print hello, Hannah. Okay, see how many. Okay, I think I have one more slide before our checkpoint. So return values, functions can also return data. You have to specify the type though. So in my example, I'm using a square function. I'm passing in a number and I want to return the squared version of that number and it should return another number. So if I pass in the number 2, it should return the square of that, which is the number 4. Okay. Hopefully that was like a okay speed for everyone. We have our first checkpoint. So the idea is we kind of put in a couple different checkpoints here just so you guys can kind of practice like writing a little bit of code on your own. So for our first checkpoint, if you guys want to write a function that takes a name, takes an age, and it returns a sentence. And I have a 3-minute timer. Maybe I'll do like 2 minutes-ish. But yeah. And then if you guys can like talk amongst each other if you want or ask for help if you need it. Huh? Oh, yeah. You? Like, yeah. Wait, do you think we're gonna have a projector in future sessions or is it always just gonna be fixed? I just feel kind of bad. I'm like talking at Yeah, but it's hard because like, can people see your mouse on Zoom if you're sharing your screen? Yeah. Oh, you can. Okay, I guess I'll just like use my mouse to talk. Stop it. Who's taking snipey pictures? Oh, oh, that's smart. Yeah, yeah, that makes sense. Okay, we could try that for next time. It'll be fine. Next time we'll have like 30 minutes to set up instead of but yeah, it was so nice. It was so like bougie. Wait, what is PS do? Do they pay for it? Because we're also in the study and they also use projector. Oh no, because
we used to do
we
this.
use Zoom because we don't want to pay for it.
That's different because that's like an internal meeting.
Oh, there's like a yeah, it's like a workshop. Like, mm, okay. Is everybody about done? Does anybody want to like share? You can come up and write it, or you could just say it out loud. Or no? Do we have like prizes? Do we have like prizes? We should do
Yeah, you want this to do?
Okay, no. Okay, the timer's up. Okay, last call. Does anybody want to take a stab at sharing like your solution or what you got or what you think it could be? There's no like writer. Okay, yeah, go for it. Yeah, you can go up to the border.
I don't know if it's right though, because I did some research to make sense.
Okay, yeah, perfect. That's pretty much, wait, what was the original prompt? Oh yeah, so the prompt was to create, okay, the prompt was to create a function that takes a name, takes an age, and returns a sentence. So yeah, he basically did that right. I'll go off the meeting now. If you guys go to the next slide, it's like a potential solution, or I guess there's only one solution. So yeah, so you can use the func keyword, and that's how you create a function. He called his greet, we called ours introduce. It doesn't really matter what you name your function. And then the way you put in your parameters was perfect. Basically, you have the name of the variable. So we use name and age, and then using the type annotations, we said name has to be of type string, and then age has to be of type int. I guess one thing that we could have added to that was the return type. So in this function, we know we want to return a string. So you could specify like using the like arrow to string after your parameters. That basically signals that this function is going to return a string. But great job. And thank you for sharing. That was perfect. Okay, does that make sense with everyone? Everyone's good? Yes, no, maybe. Okay, perfect. Okay, next we can move on to SwiftUI. So this, it might be a little bit different from what you know. This is a little bit less like basic syntax. So hopefully this part's like a little bit more exciting. Okay, so what is SwiftUI? I kind of talked about it earlier, but I could just reiterate. It's basically a UI framework for building like Apple apps with Swift. On the right, you kind of can see what that looks like. And the idea is when you're like coding or was it when you're coding on the like left panel, the little phone screen on the right will change with your updates. And yeah, so SwiftUI is used for iOS, macOS, watchOS, tvOS, so many OSs. Okay, starting with like what makes up SwiftUI. So the first thing you should know are views. Views, you can think of this as a piece of the user interface. So everything on a screen when you're on like your phone on an app, it's probably made up of like different text, buttons, images, but ultimately it's probably just some sort of combination of all these different pieces. All these different pieces can be thought of as views. So you can kind of think of it as like building blocks. And then views can contain other views, so they're nestable, and they're also reusable. So to give you guys like some more tangible examples of that, here are some different types of views. So you have a text view. This kind of like it's self-explanatory. It's like text line on the screen. So if you could see on the example, we have like a text at the top, So this is what the syntax would look like. It's just text with a parentheses, and then inside the parentheses, within your quotations, you could say what your text wants to say. So yeah, it says like I love French toast. I really, really do. So that would be what's in the text. And then similarly, there's also an image view. Again, pretty self-explanatory. This displays an image. Um, you would probably have like an assets library in your code base, and you could pull whatever you've downloaded your image as. So let's say I called my image like French toast.png. If I want to make an image view, I would just use image, like the parentheses, and then whatever the file name of the image is called. And then just one last basic view is a button. Again, it's a button. Yeah, so this is an example of a nested view because you have the button, but then on the inside, you also have that text. So the text is what's going to be saying log in, but it's wrapped around in a button view because we want like the app to still know this is a button. Um, I only included these three types of views, buttons, images, and text, but there's a lot more views. If you guys want like a more comprehensive list of everything that SwiftUI has, you can go to the SwiftUI docs. I linked it in the resources slide, but you could also just search up like SwiftUI documentation and it will go more in depth of everything it has. And if you like want to learn Swift on your own, I think it's worth it to look because you're able to like basically, let's say like you want to make a certain type of view and you don't think it exists, it might already exist and you're able to just like use what's already out there. Okay, so how do we put these different views together? We have the different like components of different building blocks, but how are we going to piece them together? So that brings us to our next topic, which is a stack. So a stack is basically when you're arranging the views in a line. So if I had like my button, my text, my image, whatever, it just like puts them side by side. But there's three different types of ways that this line could be. You could have a V stack, and this is like a vertical stack. So you have like your view, view, view. You have your horizontal stack, it's horizontal, and then you have your Z stack. And then Z stack is in layers. If you guys are familiar with, what is it called? Okay, I'm not sure. I forgot what I was going to say, but basically Z stack, I'll show you in the example later on what that refers to. Okay, so here's a diagram kind of showcasing the difference between V stack, H stack, and Z stack. Okay, so VStack, it goes top to bottom. This is probably the most common stack since, oh my God, most common stack because your phone is like vertical, right? So this is kind of an example of how you would put these views together. I use the example of login, reset password, and create account. You just wrap all your different views in like a VStack with brackets. So the syntax is down here, and then it goes top to bottom. Pretty self-explanatory. And then for the H stack, the same thing, except this time it's going to go left to right. So this would be good for things like icons and text. You know how like there's like an example that I'll show you guys in a little bit that I can show you like what H stacks are pretty like commonly used for. But the idea is it goes left to right. And then lastly, you have your Z stack. So Z stack is like back to front. And the idea is you can overlap views on top of each other to kind of create like different layers. So for example, in this diagram, you have like this fire image in the back, but then you have text stacked on top. So this would be using a Z stack. So you would have the image first, and this image, let's just say it's like my fire.png, which is my fire file. And then on top, I have my text, and it's just going to put it on top of each other like a layer. Um, but the thing about stacks, actually, that let me see if I don't know if I put these on the slides, but um, the order that you put your views in your stacks does matter because it's just going to go based on that order. So if I put the text view first before my image might cover my text. So that's something to keep in mind is order does matter when you're making your different types of stacks. Okay. Next, you can nest your stacks. Okay, so this is the example that I was referring to. In this example, if you see on the right diagram, we have like this like list, but then like in the list, there's like different, okay, this is kind of like hard to explain. There's like a list, but then there's also different like, or I can use my mouse. There's a list, but there's also like little icons and text within it. So first we'll start off with the V stack, and that's going to be the outer stack because as you can see, I highlighted it in the red. It's kind of like stacked on top of each other vertically. So all the little like blocks, I guess you could call them, are gonna make up a V stack, but then inside you can nest an H stack. So if you go to the next slide, I kind of showcased how that little location icon and the your location text, it's split up horizontally. So this could be an example of nesting stacks where you have like an H stack or horizontal stack nested within a V stack. Does the stack thing make sense? I hope the diagrams like helped. Okay, perfect. Okay. Next is a spacer. So a spacer basically pushes things apart. It stretches to fill the space. This diagram isn't like that good to be honest, but I'll show you guys a little example. But the idea of a spacer is kind of like the name suggests, it just creates space between different views. So let's say in my example, I have an H stack. I have a boy and a girl, they're standing right next to each other. If I put a spacer in between, it'll just like push them apart. And the spacer will be in the middle of them. And the idea is the spacer will grow however wide it needs to be to fit that space. So you don't really set a size to the spacer. There's ways to set size to spacing, but we can talk about that a little bit later. Yeah, so that's a spacer. Okay, next is modifiers. So modifiers is kind of how you would style the views. Right now, our views are pretty simple, but modifiers, you could change how a view looks or behaves. Is anybody here familiar with like web development, like HTML, CSS, JavaScript? Okay, you can kind of think as modifiers like the CSS portion of like SwiftUI. So you can use modifiers to do things like bold, change your text color, change your background color, the things that you would like use CSS to do in web dev. And this is used to style views. And then one thing you'll notice is modifiers are chainable. And again, order matters in this as well because it'll start at the top modifier and work its way down. So you want to make sure you're ordering them in the way you want them to apply. Okay, so here are some common modifiers. I didn't list them all. There's probably like a lot. So you can also find this in the SwiftUI docs. But here are just some common ones that you might want to use. You can bold your text, italicize, color things, change the font size, change the line height. For images, you can like resize an image if you want it to fit in certain dimensions. You can round the corners. Sometimes you guys will notice like text boxes have like a rounded corner instead of like a what is it, like a sharp corner. You could do that. You can create drop shadows and borders. And then like when it comes to things like layouts, you can add like different padding. So you can think of padding as like space. It's basically modifiers is just lets you style your UI how you want it to look. I didn't include that many like modifiers, but you can find these in the Swift UI box. So here's an example of a modifier in action. I have a text view called hello, and I'm just going to apply some chained modifiers to it. We'll start with the font modifier, and within my font, you see I have something called title. Font changes the font size. So there's different types of like font sizes you could change to. I think there's like a title, heading, subheading, things like that. So I want mine to be a title, so it'll go down top bottom. Next, I want to change the color to blue, and to change the color, it's the modifier is called foreground color. And then lastly, I want to set the background to yellow. So if you guys follow through like the slide animations, you can kind of see how it goes top to bottom. Okay, is everybody like good up to now? Okay, perfect. Oh, yes.
What was the last thing you said?
The last slide, the modifiers one. Okay, perfect. Okay, so next is state. So state is basically like the data that can change while the app is running. So I think like counters are a good example. Counters change state. You could start like a counter at 0. And then you can increase it, right? It can go to 1, it can go to 2, it can go down. Things like toggles. Toggles can be like selected or unselected. And the idea is that different views will be at different states over time, and the UI should update that automatically. So for instance, if I have like dark mode and light mode on my phone, if I select light mode, my UI should be light. And then if I select dark mode, it should automatically update to match that dark mode. Okay, so this is what the syntax looks like. There's an at state like keyword, and you just put that before how you would normally describe your variable. So in this example, I have a variable called count that's using state. It starts off as 0, but it can change over time. So what SwiftUI will do is it'll watch for these changes, and then once it notices that this variable has changed values, the UI will refresh on its own. So I included a little code snippet that kind of shows that in like context. We have our count, and then we also have a little VStack. I should have put like a little diagram showing what it would look like, but just imagine there's like a text that's saying count and a little button saying like add. And if you click the add button, the idea is that it will add to the count. And once it adds to the count, it'll change the state. So like if I were to click this button, what do you guys think the state of count would change to? Does anybody want to give it a go? 1? Yeah. Okay. And then I think Okay, yeah. So the last topic for the basics of SwiftUI, we're gonna go over for each. We kind of talked through this a little bit earlier with the for loop. For each is just one of like Swift's notation of doing this, but this is just a way to loop through a collection of data and create a view for each item. We'll be using that in our little like project demo. But the idea is this can generate dynamic views based on whatever collection you're basing it off of. So my example was like a little fruits array. And the idea is for every single fruit, I want it to create a view for that fruit. I wanted to create a text view for that fruit. So if we run through the code, we have the for each keyword. And then next to that, in the parentheses, we see that it takes in the parameters of fruits. Fruits is going to be that array that we set at the top that holds like apple, banana, mango. And then you'll notice there's this little like ID colon backslash self things. This is basically setting like a unique ID for each of these items in the array. So SwiftUI knows that each of these items is unique. And then you have your text fruit, and the idea is for each of the fruits, the for each loop will run, and then it'll create a text view for that fruit. So at the very end, the output should probably what you expect, but it'll just like, what is it called? It'll have a V stack of the different text views of the fruit. Okay, yeah. So I think that was like the intro of like the basics of SwiftUI. There's a lot more, and we'll kind of like incrementally cover new topics throughout the different workshops. So we can apply them to our projects. But this is like the first workshop. So we wanted to keep it kind of simple. But Sebastian's gonna kind of consolidate everything we've learned so far into a little mini project.
Yeah, so we'll just do like a mini, like a very, very basic app. It'll be like a one-page weather app. So I'll just like in the process, I'll just teach you how to like actually create a Swift project as well. So basically you would open Xcode like this. And can you see this? Or is it still? Yeah, okay, good. Yeah. So in Xcode to actually create a Swift UI app, not just a normal Swift file, you need to create something called an Xcode project. So you would do that by pressing File, New, and then New Project. Oh. From here on, just like select iOS app, then next, just give it a project name. Let's just call this weather app. Oh, start with 3. Yeah. Just pick your file location. Uh, and yeah, that's it. Now you're kind of good to go with your SwiftUI project. Just to kind of like walk you through the IDE here. On the left, you have all your like the whole like file structure. But for this demo, we're only going to work within one file. So we can just kind of remove this so we have more space. Uh, on the right here, you see like your actual iPhone simulator. So it's gonna like show you basically the app that you're coding in real time. And if you add some like interactive features like buttons, for example, or scrolling, you can actually test those features in the simulator. So it's very, very intuitive and very easy to use. So let's say for our weather app, we want a nice blue background and then some text on top. Does any of you have any idea of what type of stack we would use for that? If we want a background and then text on top. Yeah? What did you say? Z stack? Correct. So since we'll have multiple layers, both a background and then text on top of it, we need a Z stack, right? So I'll just start by making one right now. Just, oh, this is really slow. Z stack. Oh, like this. Uh, yeah. And from here, let's just add like a gradient background that goes from blue to white, just so it looks a little nicer. So the syntax for that is this. So for colors, you would just put in like 2 colors, and Swift will automatically like create a gradient background like between those two colors. So let's say we want blue at the top and white at the bottom. You just do dot blue here, comma, dot white, starting point, dot top, end point, dot bottom. So let's just see. Oh, what's the problem here? Just 2 seconds here, guys. Where? Oh, here. Yeah. Okay. So now you can see how we have a gradient background, but the top and the bottom is still kind of not colored. And the reason for that, this is called like the safe area of the iPhone because like those two parts of the screen, it's very rounded on like modern iPhones. So this is not a place you would like typically place important information like text or buttons. But to kind of like make our background like go the full length, just like make it look nicer, we can use a modifier called dot ignore safe area. And now you can see the gradient goes like the whole like vertical length of the iPhone. Okay, let's say now we want at the top are like the city that we're trying to like see the weather for, and then like let's say 5 days beneath that. What type of stack will you use for that? Yes, a V stack. So, pretty simple. Let's just say we want our weather app to show the weather for Los Angeles. So let's just type text Los Angeles. Okay. So we have Los Angeles now. Let's say we want to make our text a little bigger because it's really small right now. So let's just do font um dot large title. So in SwiftUI, there's like a few standard like sizes for text that Apple wants you to use. So we have like, for example, dot large title, dot title two, dot title three. So just try and stick to those. It's pretty intuitive. Let's say we want our text to be bold as well. Just do dot bold. Just make it look a little nicer. And also, let's say we want this text to be white. We then use dot font. Oh, sorry, dot foreground color. And then just dot white. Okay. As y'all can see, our like LA text is in the middle of the screen. If we want to move this text to the top, we need to like fill it with something underneath, right? Do you remember what type of like SwiftUI feature would use to kind of fill that space? Correct. So let's just add a spacer under here. And as you can see, the text got moved right to the top. But now it's like really close to the camera, right? There's like almost no space between. So we can also just add some padding here if we want to. Let's say padding 40. Now it looks pretty decent for like our simple app, right? Okay. Now let's say that we want to add 5 days of the week with like their temperatures. So let's just create like another V stack and uh, let's say we want uh, Monday, it's like 70 degrees. And then let's just add like a few more days. Okay. Right now, all of these are at the bottom. So we need to add another spacer beneath this V stack. So let's just do that. Okay. It looks okay. Let me just like modify some of these to make it a little more realistic. Like this works, right? It doesn't look super nice, but that's not our goal right now. We just want to showcase like how things work. But as I'm sure you all understand, like this works now because there's just 5 days, right? But let's say we wanted like 100 days, or you were like writing out something else and you had like a really long list. It wouldn't be realistic for you um to have like a separate like text view for every single one. It's just not efficient. You would need like hundreds of lines of code. So that's why we have for loops, right? So let's just create some list for days and for our temperatures. You would do that before the view up here. So let's just let days, which is a type of string, Tuesday, Wednesday, Thursday, Friday, right? So now we have a list for all the days. Let's add a list for all the temperatures as well. This will be of a list of type int. Yeah. Okay. So now to kind of simplify this whole setup here, let's just create a for loop like Lavender talked about. The for using for each. So here, since we're gonna access both a day and a temperature, we're gonna use indexing instead of like for day in days. So let's just do like a quick for loop, one through the length of like a list, which would be days dot count. This is a simple method that's like standard in Swift. Then, as Lavender talked about, we need to add an ID. Uh, oh, just so that Swift knows like it needs an identifier, and using like dot self just means that it's using each like list element as the identifier itself. Uh, okay. Yeah. So now we can start like actually outputting these values. So let's just have text, and then let's say we want our day and then a colon and then our like temperature. So to do that, we would use string interpolation as Lavender talked about. So just go like this, days at index. Now, well, let's change this actually. Okay, so now we have the same kind of like, we can see the same thing that we saw with the previous like version of the app, but it's way more efficient because we're using a for loop. And if we want to add like more items to our list, we can very easily just do that up here, right? I'm just gonna add one more feature because before we move on, let's say you want a button to switch between Fahrenheit and Celsius, right? Because the rest of the world uses Celsius. So to do that, we need a state variable. The reason for this is that without a state, Swift won't be able to actually dynamically update the UI. So let's create a state variable up here. Let's just call it uh, is Fahrenheit. Okay. And as you all can see, I'm using type inference here so that it's just clear to both yourself and to Swift what type of value each of these variables are going to be. So to add a button at the bottom here, let's just type button. This button we won't have like any like fancy design for this button. Let's just call it change unit. Right? Then we can add an action inside of that button. Just since this button will change our state variable is Fahrenheit, we can just use the like standard library toggle feature. So just is Fahrenheit dot toggle. Okay, so as you can see now, we have this button here. It changes the value of is Fahrenheit under the hood, but like we're not using it in any special way, right? So let's just add some extra string interpolation here to kind of show which unit we're using. So let's use the ternary operator, right? The kind of if-else statement that's way more compact, so it actually fits in just like a simple line of code. So let's say is like Fahrenheit would be our like statement. So like if this is true, we just want to show actually opposite of this. Yeah. And then yeah. Oh, this should be a question mark. Okay, so if we change this, can you see how this button works now? We just change units, and because of this ternary like if-else statement, the unit changes. Only thing we need to change here is the actual like temperature values as well. So instead of just using temps.index, we could use like another ternary if-else statement here. So let's say if is Fahrenheit, we just show the normal temperature that we already had. And if not, we need to do like a simple like conversion to Celsius. Which is, I believe the conversion is this. Let's see. Yeah, this makes sense. Yeah, does everyone kind of understand what I did here with the ternary statements and the state variable? Are there like any questions? Everyone on, yeah.
That line of code in the B stack rather than where the button is, because we press the button to change it, right? So I guess why did you put it in that location rather than putting it with the button? So when we press the button, it changes everything.
Wait, I don't really understand your question. Like why I didn't put the button closer to the rest of the text?
26, where the button is. Oh, it's 25 and 26.
25 and 26. Okay, so basically 25 and 26 is just like a it's like a for loop, right? And it just kind of displays all our days and temperature values on the screen. It doesn't really matter where this button is. Like if I want to, I can move this button like close. We can move this spacer and then put these together as well. It doesn't really matter. That's just like a design decision I made. Does that answer your question?
Not exactly. It's more like how the button is connected to that line of code.
Oh, okay, yeah, okay, then I understand. Yeah, so basically, this button, as you can see within these curly brackets, this is basically the action that the button performs when you press the button, right? And is Fahrenheit dot toggle, since like we defined our is Fahrenheit variable up here, right? Which is a state variable. And this is a Boolean. And since it's a Boolean, we can use the toggle to just kind of flip its value. So every time this action is performed, this variable kind of changes to the opposite value, right? So if it's true to begin with and a toggle is performed, is Fahrenheit will change to false. So you can think of like this button being connected to this state variable. And then for the for loop, like this for loop isn't like directly connected to the button. This for loop only reads the value of the is Fahrenheit and kind of decides which type of information to show based off of that.
I see. Thank you.
Does that make sense?
Yes.
Okay, good. Any other questions? No? Okay, let's move on to the rest of the workshop then. What happened here? Yeah.
Okay. Yeah, so we went through like the little demo, and the idea was you guys could kind of see in action all the things that we were learning about at the beginning, the Swift and SwiftUI. But we also wanted to cover some more like advanced topics, and the idea is you can use some of the things that we're about to teach. These will probably come in handy more like when you're making actual apps, when you'll need more like complex syntax. So starting off with, let me see, hold on. Okay, starting off with default values. So this is going back to functions. Basically, remember how when you have a function, you can pass in a parameter, and the function kind of uses whatever parameter is passed in. It can use it when it's running its own body. Parameters can also have a default value. And if you have a default value with that parameter, it's kind of like self-explanatory, but the idea is it'll make that parameter optional, because if you weren't passing in that parameter, it would refer back to that default value. And the idea is this makes functions easier to call, and then also reduces repetitive code. Let's say there's like two versions of a function, and one of them you could just use as the default in case you didn't want to like keep having to define it. So if you go to the next slide, there's an example. So I have using that same greet function. I know it was a while ago, but for our function slide, we made this function called greet. And the idea is it can just say like hello, and you can pass in a name. But let's say if I didn't want to pass in a name, I can set a default value to hacker, or you could set it to whatever you want. But in my case, I'm setting this default value to hacker. And if you go down to over here where we greeted the first time, you see that I didn't pass in any parameter, but it's still going to output hello hacker. And if you come up here to the syntax, you just basically set whatever the default value is equal to the parameter. So it would look something like this, but then you can still use this same function how you might normally use it by passing in a parameter. So if I wanted to greet Kayla, I could say like, okay, greet, and then name equals Kayla. And then it would ignore that default, and then it would print out hello, Kayla. Does that make sense to everyone? Okay. The next important topic is errors. I'm sure you guys have all dealt with this if you've coded before. There's a lot of things that can go wrong, obviously, especially in an app. Let's say like I know a pretty common error you've probably encountered, like making different types of passwords for different apps. Sometimes it'll be like too short. Maybe your password doesn't have the right characters that it needs. So Swift forces you to handle all these different failures safely. And safely is basically making sure the app doesn't crash. So the idea is you can define different types of errors using that data structure from earlier called the enum. And remember, an enum is just grouping related things together. So in my case, if I want to define different types of password errors, let's say I have like a list of different errors that I think would come up. It could be like, okay, it's too short, it's too obvious. So I could group these all under an enum. And then in order to handle them, I would use something called a do, try, catch block. So I'll try to like run through this with the little like red blocks to show you guys. So we start with the do, and you'll just execute everything within this do body, and then try. So let's say we have a function called check password, and if the password is valid, it'll like return true. If it's not valid, it will return false. So let's say my password is 123, and I want to like see if this is okay. Basically, I can run the do, and then it will run the try. And then if it passes like my check, it will just print password okay. But let's say this doesn't meet my like standards, and I think this is too obvious of a password, then we can catch it, and it'll go down, it'll skip this print statement, it'll go down to the catch, and then it'll end up printing, okay, there was an error. Okay. The next topic is closures. So closures are anonymous functions that you can store in variables. And then you can pass them around like a variable that I can in the next couple of slides, I think we have like examples of that. But the idea is a closure you can think of as a function, but it's treated like it's a variable. And some popular use cases for this could be running code after a task finishes, responding to user actions, and especially it helps you make like reusable small functions. So this is what the syntax would look like. So notice here when I'm declaring this is a closure. When you declare a function, you use the func keyword, right? But notice in this closure, we're using the keyword let, and let is how we declared our variable. We're not using the func keyword. So that's kind of what I mean. Like you treat it like a variable, you declare it like a variable, but then inside, instead of just assigning it to a value, I'm assigning it to this like body that's nested in the brackets. And this part kind of looks a little bit more like a function. And yeah, so then if I wanted to call this, if I wanted to call this, oops, sorry. If I wanted to call this, I could just call say hello, which is the name of the function, but I could just like call it like a normal function and it would still run and I could say hello. And then similar to functions, closures can also accept parameters. This is what the syntax would look like. Again, we have the let greet, so it would still be kind of defined like a variable using that let keyword. To take the parameter, you would have these like parentheses and you would put your parameter list inside that. And then you have your in keyword, and the in keyword separates the parameters from the body of the function. So we have our parameters here, we have our in keyword as like a separator, and then this is what the body of the function would be. So if I wanted to call this function, but I wanted to pass in a parameter, let's say I want to greet Jeff, it would just run kind of like a function, right? It would run the same way. It would just, you can pass in that name and then it will run that body. I don't know if I think these slides aren't like as comprehensive as they could be, but do you guys kind of see what I mean where it's like a function, but it's just treated like a variable? Does that make sense? Okay. Okay. And then next, passing functions into functions. This kind of goes along with what we were talking about, how you could treat like these different functions like a variable. So in Swift, you can think of functions as if they're or you could treat them like they're values. So values are like numbers, strings, booleans, things like that. And the idea is you can pass a function as an argument to another function. So if you come back to like these old examples, for the most part, we've just been passing in different types. So things like strings, ints, but we've never passed in like an actual function, but you could do that if you wanted to. And some use cases for this is you can repeat an action multiple times. You can control behavior dynamically, and it's especially useful for event handling and animations. We won't talk too much about like these topics today, but I think that's something we'll definitely focus on a little bit more in later workshops because I think that's pretty like important to mobile development. So here's like an example of passing in functions to functions. So on my left side, I defined a couple different functions. I have a jump function and a dance function. They're both pretty simple. All they do is just run a sentence. And then on my right side, I have another function. And as you can see here, this is an example of a function that takes in a function as a parameter. So up here, we have like the name of whatever our parameter name is. And then if you see here, like the parentheses that lead to void, this indicates that it's taking in a function, and then this is just that return type, kind of like how we talked about return types earlier. So if I wanted to run this function, let's say I want to call this function perform action, and the function that I'm going to pass in jump. So we can go up to this jump function. We know that if we were to run this, it's just going to print jumping. If this were to run, does anybody have an idea of what might be outputted based on the perform action function? You can just like say it out loud. Yeah. Yes, that's exactly right. So that's what it would be. So notice how it was able to take in like a function, not a string. And that's just the idea that you can call or you can like pass in functions into other functions. So similarly, if we were to pass in dancing or the dance function instead, it would do that. Or it would like output that same thing, but it would replace it with the dance function. Okay, so for our second checkpoint, if you guys or Yeah, let's see. I think we're good on time. So for our second checkpoint, it will be to write a function that accepts a number, accepts a closure, and then runs the closure that many times. And I'll set another timer for 3 minutes. And if you guys want to refer back to like the slides for the syntax, feel free to. We could do like 2 minutes.
I'm gonna go.
You don't have to go through all this, like super do the demo part.
Just keep playing.
Just give them and then start it off next time. Because I think this stuff all is gonna start coming in handy later on. Do you know what I
Just
mean?
keep like advanced and
Yeah. Yeah. Or what do you think? Wait, do you use any of your stuff? Yeah, you do. This is struct. Yeah, I think we just stop here and then next time
at least
part.
for my part plus done.
No, don't do the demo. Don't do the demo.
Okay.
Just talk about it. Just talk about it and then that's when we can start off. Because I think things like structs and error handling, like they're gonna need to start using, right? Like what's about it here? Like what would not use that struct?
That's what I'm saying.
Okay.
That's why it's useful.
Yeah. So you still need to learn it. I think it's chill.
Just skip class.
Wait, which one comes first?
Structs.
Yeah, just talk about structs.
Yes.
Yeah. If there's no time, you could do classes.
Just skip class.
Yeah. Okay, does anybody want to give it a go? You could say it out loud, you could say part of it for this checkpoint. I'll wait for the time to run. It says something. I'll just be like, okay. Look, yeah. What time is it? Should we just do it? Yeah, I'm just
It doesn't matter. It's almost yeah. So the problem is with mine.
Let's go watch the fucking women's basketball game with Aggie after this for a coffee.
Women's
Yeah. He said either that or something like on the IM fields, but I don't want to play sport now. Okay. 3 minutes like about up. Okay, last call. Does anybody wanna like try? Okay, no, it's okay. Here's what the solution would look like. So the idea is to create a function that accepts a number, a closure, and runs the closure that many times. So here's my solution up top. I should have like boxed this off to like explain it better, but I'll use my cursor if you want to follow along. So I wrote my function. I have the func keyword here. I named it repeat function. And what does it do? It accepts a number. So you could see in the parameter list here, we have two different parameters. We have one called count, and I want it to be a number. So the type is going to be int. And then my second one is going to be an action or a closure. So I'm going to call that action. And then the closure, remember, it's like a function, right? So if you remember the syntax from earlier, it would just be this like empty parentheses. And then you could see the return type is void. And then the actual body of the function was supposed to run the closure that many times. So we could just use a for loop. We can iterate from 1 all the way through the count, which is what we like passed in as a parameter. And then we could just run that action. And then if I were to call this outer function, repeat function, and I were to, I guess I did not fix this. Imagine I put in a closure and the closure was to print out, I love SwiftSchool. This is what it would output. Yeah, sorry, that's a mistake, but hopefully you guys see the idea. Does everybody understand like the solution part of it though? Like on the top? Okay, perfect.
Yeah, so the final topic we're gonna cover today, because we're almost running out of time, is structs. And structs in Swift is basically a way for you to create your own custom data types. So like structs are super like fundamental in Swift because all the data types you've been exposed to already, like ints or strings or doubles or arrays, under the hood by Apple, they're all implemented as structs. So structs are basically a way for you to create your own custom types. Have any of you been exposed to structs in CS32 perhaps? Only one? Okay. Yeah, okay, basically, they have the same name, but there are some like clear differences between C++ structs and then Swift structs because in C++ structs only hold some like they can only hold like basic variables, right? There's no functions or initializers or anything like that. So that's perfect for, let's say, linked lists. But if you want something more advanced, you'll have to use classes. However, Swift structs are more similar to C++ classes actually, because Swift structs can have initializers, they can have functions, you can implement access controls. You can basically do whatever you want with structs in Swift. So yeah. And this is what a basic struct would look like in Swift. So the way you would like define a struct is to just use a struct keyword and then whatever name you want to give that struct. And the general convention in Swift is that for types like ints or doubles or list, you have the first letter capitalized. And since you're essentially creating a new type when you're creating a struct, you should kind of like follow that convention as well. So yeah, at the top here, first line, struct and whatever name to like just give it a name. We also have three variables down here. Like within a struct, we actually call these variables properties. So from now on, I'll just refer to them as that. Otherwise, you can just like define these properties as you normally would, like anywhere else in your file. And then at the bottom here, we have a function. Functions within structs are called methods. And again, you can just define a function like you normally would, just as long as you keep it within those two brackets. And as I said, like at this point, this album struct is basically like any other type. You can make new ones, you can assign values, you can copy them, you can put them into lists or arrays. It's basically just a new type that you've created. But you might wonder, like, how do I actually assign a struct to a new variable, right? Because, for example, in the album I showed you, there's three properties inside of that struct. So you won't be able to use like a normal, just like x equals 5, for example. So the way this is done in Swift is by using something called um, an initializer. So this is basically a special type of function that Swift automatically creates for you when you define a struct. So you basically just treat it as any other function. You just use your struct name, and then in parentheses after, you can give each property whatever value you want. So here, for example, I'm creating album red with the title red, artist Taylor Swift, and the year 2012. So yeah, just treat it as like a normal, you can kind of treat it as a function. And then to actually access all the properties of the structure you just created, we use something called dot notation. So you basically just put your like struct variable name, dot, and then the property you're trying to access, like this. So for example, the first statement here would just print the title of red, which is red with a capitalized R, and wings.artist would print BTS. So it's pretty intuitive in that way. And for actually modifying these property values after you initialize a new struct variable, there's two main ways to do this. They can either be modified directly through dot notation, like this. So here we have just a person with a name and an age. And here I'm initializing this person to be called Sarah, and Sarah is 20 years old, right? Here to like actually modify her age, I'm just again using dot notation and incrementing her age by 1. It's pretty simple. And this works right now because we haven't like created any like access restrictions on this struct. So this is fine for now. But in general, the like main way you should use to modify property values of a struct is through internal methods. So for example here, inside of this person struct, I've defined a method called increment age. And what increment age does is it just like raises that person's age by 1. And to actually call this method, you can just use dot notation again. So Sarah dot increment age. The only difference here between like a normal function and a function that actually modifies an internal property is that you need the keyword mutating in front of it, just so like Swift knows that this function is gonna modify one or more of your internal properties. Any questions on that, or does it make sense to everyone? Good, great. One more thing about like initialization and stuff is that you can actually give default values to these properties, right? So let's say let's say I want to create a person and I only know this person's age. I don't know the name yet. So I just want the default value of like anonymous for name, right? It's really simple to just set a default value. You just do equals anonymous. And this will basically act as a fallback. If you like, as you can see at the bottom here, I'm initializing a person without giving a name. In this case, the name will just automatically fall back to anonymous, right? And yeah, Swift kind of automatically creates a new initializer that kind of handles creating a person without a value for each specific property. Swift also gives you the opportunity to create custom initializers. So as I said, like Swift automatically generates an initializer for you, but in some cases you might want some special random value, or you want to compute a value when you initialize like a new struct variable. And this is done using the init keyword. So here, let's say I have struct player and I want the player number to just be a random integer between 1 and 10, right? To do this, I would have to create a custom struct, and I do this using the init keyword. This is basically just you defining a function. The only real difference is that you don't have to like use the func keyword in front, and you don't need like a return value either because it's a special type of function within Swift. One more thing you also have to remember, it's like a little confusing, but since you're kind of modifying the struct itself, you need to like refer to the struct's internal properties, and you do this using the self dot notation in front of the name. You don't really need to know like the exact mechanics of why this is important. Just remember when creating custom initializers that you need to use self dot before the property that you're trying to modify. 5 minutes, yeah. One other like really important feature of structs is access controls, because in many cases we want to limit who and how these properties in a struct can be modified. I'll give an example on the next page, but you basically restrict how properties can be accessed through a keyword you just put in front of that property. So there are 4 main types here. Either a private property that can only be accessed from within the struct. So what I mean by that, it's like these properties can only be changed by an internal mutating method. We also have file private, which means that the property can only be accessed from within that specific file. So that means like let's say you have like a bigger Swift project, other files in that project won't be able to like modify or even read the value of that property. Then we have public, pretty self-explanatory. Anyone can access and modify these properties. And then finally, private set, which is actually one of the most useful ones in my opinion, which basically means that the value can be read from anywhere, but it can only be modified from within that struct. And I'll give an example on where this would be useful. So let's say I have a bank account struct and it's initialized with $100 in the bank. As you can see beneath here, we have an internal method called withdraw that when it's called, it actually checks if there are enough funds in your account to like actually withdraw that amount, right? So if I call withdraw 500, it's going to return false and not withdraw anything because I only have $100 of funds, right? But since there's no access control here, there's nothing stopping me from just doing using dot notation and withdrawing $1,000 from this bank account of $100, right? So since there's no protection here, I just put this unfortunate person like $900 into debt, right? So this is where access control comes in. Does any of you have an idea of which keyword would like make sense to use here? There are actually multiple correct answers. Anyone? Okay. So for this case, I think it would make sense to use private set so that the user can actually like he can read the value of how much funds he actually has in his account, but it can only be like actually accessed through an internal method. So it's very simple. You just add this keyword in front, and now our funds variable is protected. And this line of code at the bottom here wouldn't work. It wouldn't be valid. Yeah. So just finally, we have 30 minutes left. That's perfect. I want you all to try and create a struct that stores information about a car. So include its model, the year it was built, and the current gear. And also, if you have time, try and add an internal method that can change the gears up and down. Also, if you have any questions, just like raise your hand and I can come help you.
It's 7. Oh. 7:59.
Yeah, we're done.
Oh. Or after.
Hmm?
Like after. Shouldn't go to the finals.
Yeah.
You should be like, oh, thanks.
No, so init is just like a special type of function. It's like an initializer. So you don't really need to use func or mutating or anything like that for init. There's only init. For any other methods that actually changes like an internal property, you need to include the mutating keyword in front.
So whenever I want to make another function inside a function and change the property altogether, that's when I use mutate.
Yes,
But
exactly.
if I just want to change it generally without actually changing the properties, I would go for
Oh no, so like init is when you actually create a new struct, right? It's just for that one case when it's actually created. For like all like every other like case, you would use a normal function. Init, you can think of init as like a one-time use function.
I see. So generally, we wouldn't want to use that then as opposed to mutating to make a new struct.
No, so like init is just you don't need an init first of all. It's like automatically generated. It's just if you want like a special type of like initialization process when you create a new struct, you would use init.
It says the other way around. It's usually, we would usually use mutating.
Yes.
Not init.
Yes, exactly.
Okay, and we don't use it because we create a struct inside of our struct or type of function, and it just wouldn't. Actually, that part I don't really get. What other labs actually?
Wait, do you want to maybe go over that afterwards so we can just
Yeah,
wrap up
wait, I can
first?
explain to you after we're wrapping up. Yeah. Yes, does anyone want to show or like
Wait, sorry, I think we could just wrap. This is like time.
it's fine. Does anyone want to like have an idea or at least wrote some code down? No? Okay. So this is the solution that I wrote. Pretty simple, just define a model of type string and a year of type int. I also set the current gear as a private set, so like people can like read which gear that car is in, but not modify it outside of our change gear function. I also decided to create an enum for our gears because you can only change your gear up or down. So I just had like two cases for that and use a switch statement. Is there anything about this syntax that's difficult or you want to explain in more detail? No? Okay, so that's that's all we have time for today, unfortunately. I have some slides about classes that you can go through on your own afterwards. But yeah, thanks for coming out today. I know it was a lot, but we believe it'll like make it easier for you during our next workshop when you'll actually like start building like real apps. And is there anything you struggled with today that was difficult or just want to like revise it more to understand it better before next workshop? We'd highly encourage you to check out 100 Days of Swift. There's like a guy there that's made like very short, but like well explained videos that go into each topic in great detail. Oh yeah, one final thing in Xcode, you need to like actually create web apps, no, mobile apps. You need an emulator. I'll just like you see here real quick. You just open Xcode settings, components, and from there on you can just download the simulator. Yeah, hope to see you all next week.
Learned something.